Today's episode of Just the Tip Tuesday is brought to you by FCAW Worldwide, the standard in TIG welding. If you need torches, parts, consumables, or accessories for your TIG welding applications, whether at home or at work, go check out FCAW Worldwide. FCAW has revolutionized the TIG welding game with several different types of TIG welding torches, cups, collets, collet bodies, gas lenses, and gas cups. I'm currently using their FlexLock 230 water-cooled torch with a gas lens and super cups, which are made of silicon nitride. The super cups withstand high heat applications, high amperage, and high heat reflective applications, and they last longer than the standard aluminum nozzles we're also familiar with, and they resist cracking due to thermal shock. Head on over to ckworldwide.com today and check out their full selection of parts, torches, consumables, and accessories. You can only get genuine FCAW Worldwide products through an authorized distributor, so make sure to check out the Find a Dealer tab on their website to find the closest supplier near you. FCAW Worldwide, the standard in TIG welding. Now let's get into the show. Welcome to this week's episode of Just the Tip Tuesday, brought to you by FCAW Worldwide. Today's question was submitted via Instagram by Justin Damron, and Justin asked if I could cover FCAW, both self-shielded and gas shielded for the home hobbyist. Justin, we can indeed talk about this topic, and thank you so much for sending in your question. Let's go ahead and define FCAW for those listening. FCAW stands for flux cord arc welding, and this process can be ran with or without gas to an extent. We'll get into that momentarily. When it's ran without gas, it's called self-shielded because it creates its own shielding gas based off the flux on the inside of the wire. When it's ran with gas, it's called gas shielded, or more commonly referred to in industry as dual shielded, which is actually a non-standard term since dual shielded is actually a brand of gas shielded flux core wire from FCAW. Kind of like when we make a copy and a lot of folks call it a Xerox, or instead of looking something up on the internet, we call it Googling it. It's kind of like that. But the proper term is indeed flux cord arc welding, gas shielded or self-shielded, depending on what we're talking about. Now, you really don't need to know that unless you're prepping for the CWI exam or you're reading a welding procedure spec. But I figured I'd go ahead and drop that little bit of knowledge on everyone since it came up. The first type of wire we're going to talk about is self-shielded, and it's exactly what it sounds like. It's self-shielded, so we don't need any gas. Additionally, with self-shielded wire, we can't use gas. Likewise, if we run gas shielded, we can't run it without gas. Each type of wire is going to be designed for a specific use, whether it's with gas or without gas, and it's not interchangeable. So don't go adding gas to a self-shielded wire, and don't be taking gas away from a gas shielded wire. It's not going to work out well for you. Flux cord wire is very similar to gas metal arc welding, or MIG, but instead of using a solid wire, it has flux on the inside of the wire. So think of it as a welding rod sucked inside out. There's flux in the middle, and then there's a metal casing on the outside of the wire. Flux cord and metal core wires are made from something called strip. Now what they do is they take this strip and they run it through a bunch of rollers and dies, kind of in the form of a taco, out of this strip that they start with. Then they start adding the flux and they send it through more rollers and more dies to wrap the content inside the wire. It's actually a really cool process to watch, and it happens at an extremely high rate of speed. I actually had the opportunity to check this process out once up at Lincoln Electric in their Mentor facility in Ohio, right outside of Cleveland, and then again at the Select Arc facility in Troy, Ohio. It's insane the amount of flux cord wire that they produce in a single facility in one day. I think Lincoln said they made enough wire per day to wrap around the globe 2.5 times. Nerd alert, that's 62,253.87 miles per day. So obviously, if one company is making that much wire per day, it's probably a good choice for a lot of our welding needs. So which is best for the home hobbyist? Well, it's really going to depend on the type of work that you're doing, what equipment you have access to, and how portable you need it to be. So let's go ahead and start with a process most at-home welders are going to be familiar with, and that is flux cord arc welding self-shielded. Let's talk about some of the advantages of this process. It's done without shielding gas, so I don't need to make that extra purchase. I don't need to buy an additional bottle. I don't need to buy a flow meter. Don't need to buy hose. Don't need to worry about the wind or any of that stuff. It's more efficient than shielded metal arc welding. So shielded metal arc welding has a 60% efficiency rate, meaning that if I buy 100 pounds of stick electrodes, 60% of that is actually going to be converted into weld metal. Whereas with FluxCore Self Shielded, it's got an efficiency rate of about 82 to 85%. So if I buy 100 pounds, 82 to 85% of that, or 82 to 85 pounds, is going to be converted into weld metal. It has a very high deposition rate, so I'm putting more metal down per hour with this process. It has good mechanical properties. It has scavengers inside the flux that are added to remove oxygen and nitrogen from the weld puddle. So scavengers are elements like titanium, manganese, and aluminum, which are going to help remove contaminants and keep oxygen and nitrogen out of the weld. So the base metal doesn't have to be too clean when you're using this process, so that's kind of an added bonus as well. Additionally, I can use this stuff outdoors. Some of these wires, not all of them, they're actually rated up to 50 mile an hour wind gusts. Not that I want to go out and weld in 50 mile an hour winds, but if I had to, this would be the process I'd use. The equipment's pretty simple, meaning you don't need anything too fancy to run this wire. Most of the machines from Home Depot, Lowe's, and if you're balling on a budget, Harbor Freight, can run these wires right out of the box. It's also highly portable. Like I said, all you have to do is take the machine with you, and then your extension cord or, whatever wall outlet, you don't have to tote around a bottle, flow meter, and all that other stuff. Now, all that sounds great, right? But as with anything in life, there's a downside as well. So let's talk about some of the disadvantages of this wire. There's a lot of smoke. It's definitely best suited for outdoors. So if you're going to be welding in the garage, you got the doors closed because it's winter or something like that, it's probably a good idea to get some at-the-source fume extraction or figure out a way to mitigate that smoke. The last thing you want to do is fill your garage up with this stuff. There's also going to be a lot of spatter. It has a violent and erratic transfer, usually a globular transfer, so it can get messy. And then on top of that, we have to, there's slag associated with this process. We're going to have to chip that off after every pass and clean it up. And then especially prior to painting, we're going to want to get rid of some of that slag and that spatter. Additionally, restrikes can be a little bit difficult. It's not too bad. I usually trim my wire at like a 45-degree angle, and that seems to help it out, strike off a little bit better. A lot of people just kind of snap the wire end off because it's very brittle wire, so you can snap it and break it pretty easily. But I've found that if I take a pair of Welpers or a pair of dikes and I cut it at that 45-degree angle on the end of the wire, it seems to light off a lot easier. I used to run a lot of self-shielded FluxCore when I ran my own business. Why is that? Several reasons. As I mentioned earlier, it's faster than stick, right? I'm out there, I want to get the most amount of work done in the shortest amount of time because it's Florida and it's hot and it sucks being outside and it sucks welding outside. So I want to try and make my time out in the field as efficient as possible. I'm also able to make longer welds, whereas with stick, I can only run about 6 inches at a time. Another reason I ran self-shielded is because I can buy that wire on the weekends. Most of your welding supply stores, they close at 5 p.m. on a Friday, and they're not open on weekends. But guess who is? Home Depot, Lowe's, Tractor Supply, Northern Tool, and several other stores, and they usually carry a pretty damn good selection of self-shielded wires. So convenience is also another factor when choosing self-shielded over gas-shielded for the home hobbyist. The last thing you need is to have everything set up for a weekend project, and you pull the trigger at 5 p.m. on a Friday to find out you're out of wire. Most of your big box stores, they're open till 10 p.m. on Friday, and they reopen Saturday at 6 a.m. Boom, no problem, you're back to work. One other disadvantage with some of the self-shielded wires, and probably the biggest disadvantage in my opinion, is that some of these wires, they're limited to the material thickness. There's certain wires out there like the E71T and E71T-G that are limited to 5/16, ½ inch, and 3/4 inch plate thickness, depending on the diameter of wire you're running. So for instance, we used to run a lot of 045 on 3/8 plate until I found out, hey, that's a no-go. It's only good for a 5/16. And if I'm putting like ½ inch of weld metal in there because 3/8 plate plus 1/8 inch weld reinforcement, that gives me a ½ inch. That's not suitable. This stuff's going to crack. We do bend tests on this stuff and it would snap. That wire is not designed to do that. So be sure to check out and make sure that the wire you have is going to be suitable for the job that you're going to do. If not, your weld's probably going to fail due to filler metal dilution. You won't have that problem with stick or gas shielded flux. So when in doubt, stick it out. I really like self-shielded for like sheet metals, 1/4 inch material, galvanized. It works great on galvanized. Filling in pour fit-ups, doing handrail installs and repairs. There's a lot of great uses for it, and for a home hobbyist doing general fabrication and repairs on steel, you really can't go wrong with Self Shielded. Most people don't like it because of the amount of spatter, but if you can get that machine dialed in and you scrape off the spatter in between passes and as you go with the chipping hammer, it's really not that bad. Now with gas shielded flux core, I love this stuff. It burns super hot and it burns super clean. It's a great choice for welding on thick materials in all positions. Self-shielded flux core, you can run that pretty much all position as well, but with gas shielded, it's really good on thicker materials. Most heavy fab shops, they're going to run gas shielded flux core because of how well it runs, how deep it penetrates, and how fast this stuff burns in. It's really hot stuff. Some of the advantages of gas shielded flux core are excellent bead appearance. Like I said, this stuff lays in super smooth and super clean if you do it right. It has a clean spray arc transfer. Little to no spatter because of that. The flux usually just falls right off. There's really not a whole lot to clean up other than sweeping up the flux off the floor if you do it right. It has high deposition rates, meaning you can put a lot of weld metal down in a short amount of time. It's got deep penetration, like I said, and it's efficient, so you're depositing more weld pounds per dollar than compared to stick welding. Now that we know the good, let's go ahead and talk about some of the bad. Smoke and fumes are the first one. So once again, make sure you're not running this stuff inside a garage with closed doors. Make sure you've got some sort of fume extraction. Maybe set up a fan next to a window, do your welding by the window. Keep your head out of the fume plume. You'll be all good to go. Just make sure you're not doing this stuff in an enclosed space. Another disadvantage is portability. It's going to require an externally supplied shielding gas, like 75 to 85% argon, with CO2 being the mix of the balance for the remainder. It's not going to weld good in outdoors. So if you have wind coming across, blowing your shielding gas away, it's not going to work really good for you. It does have the potential for gas marks, also known as chicken tracks or wormhole porosity. It also has high radiated heat. So if you're going to run this process, I highly recommend using one of those aluminized backhands on your glove. It's just going to help you out a lot better. It's going to keep the blisters off your knuckles and the backside of your hand. And it's also limited to thicker sections of base metal. So this isn't something you're going to want to run on 1/4 inch material or anything less than that. You're going to want to use some thick material on this. So for a home hobbyist perspective, gas shielded flux core may not be the way to go. The machine to run it's going to be a little bit more pricey, and you're going to have to get your wire and gas at a weld supply store before you need it, and make sure you have everything on hand before your project, before 5 p.m. on a Friday. Although I have seen a few Tractor Supplies selling welding gases like argon and mixed argon and CO2 bottles, and they have refilling stations as well. But these are few and far between, and they are damn proud of their gas. So you're going to pay an extra bit of money for a convenience fee on a Saturday or Sunday refill. Additionally, if you're not welding thick materials or heavy sections, you really don't need to run gas shielded. But if that's actually what you're doing, by all means, run over and go ahead and switch over to gas shielded. But like I said, I love this process, but in all my years of working in my garage as a home hobbyist or picking up side work or little projects, I've never used gas shielded for any of my projects. It's either stick, solid wire MIG, or self-shielded flux core. But in a shop, I'd run gas shielded all day if I could instead of regular solid wire MIG. It just runs so much better. It's so smooth, and you get better deposition rates, better penetration than you do with solid wire MIG, and it's good for heavy sections. A couple things we want to make sure of, regardless of which process, whether it's self-shielded or gas shielded, is to first make sure it's set up properly. Most of your self-shielded wires run on DC negative, meaning your workpiece clamp should be on positive and your gun should be hooked to the negative. You want to make sure what polarity is recommended for the wire you're using. It's actually written on the box, or it should be written on the box. Sometimes it's even on the label of the spool. If not, you can always look up that number on Google, and then it'll tell you exactly which polarity to run it on. Some self-shielded wires, they also run on DC positive, so you have to be careful. So in this case, if it's on DC positive, your workpiece clamp is going to be on negative and your gun's going to be on positive. That's usually the first question I ask when someone asks me for help with self-shielded. What wire are you running and what polarity you're on? You'll know almost immediately if you're on the wrong polarity because it can run like garbage regardless of the settings, so make sure to check that first. Now remember, with self-shielded, some wires are DC positive and some are negative. But when it comes to gas shielded, all of your gas shielded wires are going to run on DC positive. If that's the case, you're going to put your workpiece clamp on negative and you're going to hook up the gun to the positive. There's really no question with that. I mean, DC positive runs very similar to stick and solid wire MIG, so you can't get that messed up. But if you're running into some issues, you can't seem to get that wire dialed in, go ahead and check polarity, which polarity you're supposed to be on if you're running self-shielded wire. With either process, you're also going to want to make sure you have the correct drive rolls. If you're running 045 flux core wire, self-shielded or gas shielded, you want to have the correct diameter rollers, and you want to make sure that they're knurled, meaning they have little ridges or teeth in the grooves. This is going to help tremendously to prevent feeding issues. Don't try running your 045 flux core wires with your 035 V-groove wheels. They're meant to run solid wire MIG. You're just going to end up cranking the pressure down too tight on the rollers and flattening your wire, so it's not going to feed correctly, and you're going to have feeding issues, and it's really going to piss you off. So make sure you've got the right diameter and the right type of rollers for that process. Another common problem I see all the time with flux core wire, whether it's self-shielded or gas shielded, is the stick-out length. Most people try to run this with a very short contact tip to work distance, just like they're running solid wire MIG. You need to give that contact tip some space, like 5/8 to 3/4, sometimes more than that, depending on the diameter of the flux core wire that you're using. You see, what happens is that flux on the inside of that wire, it needs time to preheat. And if you don't give it that space, that flux is going to go into that puddle cold, and it can't do its job. And you're going to end up with severe porosity. So make sure you have the right contact tip to work distance based off the diameter and type of flux core wire that you're using. As I've mentioned in several previous episodes of different podcasts, you can always check out, the type of wire, the diameter. You can pull up a whole spec sheet that's going to tell you what wire feed speed, what voltage you should be running, your travel speed, contact tip to work distance, the type of polarity, what gas you should be using, if it's any at all. All that information is going to be on the spec sheet. Most manufacturers are making this readily available just by a quick Google search. So to conclude, I'd say for about 90% of the home hobbyists, self-shielded is going to be the way to go. It's going to be your best bet when it comes to any flux core welding process. But if you're getting into thicker stuff and all you have is self-shielded meant for like thin gauge material or solid wire MIG, which is only good for 5/16, go ahead and switch over to that gas shielded. Remember, solid wire MIG is only recommended for 5/16 and below for material thickness. And for some self-shielded wires, like I said earlier, they're only good on 5/16, 1/2 inch, and 3/4 based on the diameter of the flux that you're running and the type of wire that it is. But most of the time, self-shielded would be my way to go. Now, definitely don't get me wrong. There's some, self-shielded wires that are meant for unlimited thickness materials. Just make sure you check the spec sheet. Make sure you have, the type that you need for the application. Most of the stuff you're going to be able to buy at your local big box store is that wire is going to be meant for 1/2 inch thick material and below. And that's probably what most, home hobbyists are working on, on the weekends anyway, probably even less than that, maybe 1/4 inch and less. So Justin, I hope that sheds some light and it helps you decide on which process to run for your next project there at the house. Thanks so much for submitting your question. If any of y'all have a question you want answered or a topic you want discussed on Just the Tip Tuesday, go ahead and shoot me an email, show@arcjunkies.com. You can drop me a DM on Instagram @Junkies Podcast, or just hit the send us a message button at the bottom of the Arc Junkies website at arcjunkies.com. I appreciate y'all listening, and until next time, make every weld better than your last.